right, our review for our Unit 2 test is here. So make sure you get this down, make sure you understand what we're doing and all this. Here we go, number 0. When the slope is opposite reciprocal. Okay, so opposite reciprocal is perpendicular. You gotta know that. Perpendicular. Right? When the slope is the same, now that's parallel. Cool. Now, number 2, if two lines are not parallel and not perpendicular. Okay, usually we would say neither, but there's a special name for that. If they do intersect but not at 90 degrees, we call that skew. Okay, that's a vocab word. All right, number 3, given the equation of a line is y equals 3/4 x minus 1, write the slope that will make the equation parallel. Now remember, parallel is the same. And if you remember, y equals mx plus b, the slope is the m, so the slope is 3/4. So if it's supposed to be the same, then my new slope would also be 3/4. Cool? Now, given the equation y equals negative 5x plus 7, write the slope that will make this equation perpendicular. So there are 2 changes, right? It's opposite and that's the positive. Oh my gosh. The opposite is the positive negative sign. And then the reciprocal that's the flip. Okay. Now, this slope is negative 5, right? But you got to put it over 1. So what is that going to turn into? Well, you have to change the sign. So negative becomes positive. Reciprocal, I flip it, and I get positive 1/5. So please notice, if you have a whole number, you got to put it over 1. And then, for perpendicular, you do the 2 changes. Cool? All right, 5 through 9. All right, so we have our vocab here, our word banks at the top. We want to know what is angle 1 and angle 5. Now notice they're on the same side of this transversal, but one is out and one is in. So that's the weird one. When it's on the same side, one in, one out, okay, we call that corresponding. Sorry, my pen is giving me trouble here, which is A, okay. And something you got to know, if you look at it, they're both acute, they're in the same position, they're in the same zigzag. Corresponding is congruent, okay? Now I want you to notice something real quick. On these answers, again, when it says consecutive, you can think of that as same side. Same side. Cool. All right, number 6, 3 and 6. So 3 is right here, 6 is right here. Now here's my transversal again. 3 and 6 are on the same side, and this time they're both in between the 2 parallel lines. So that would be same side interior. Or consecutive interior, which is letter D. Okay. Now remember the S rule, same sides are supplementary. Cool. Flip it over or flip to the next page. And we have our word bank still here. 2 and 7. So here's 2. Here's 7. Once again, here's my transversal. They are on the same side above the transversal, but instead of being in between the parallels, now they're outside the parallels. So remember, our word bank. Consecutive is the same thing as saying same side. So 2 and 7 would be same side, exterior. And like we've said before, same side is the S rule, supplementary. Cool. 2 and 8. So here's 2, here's 8. On the transversal, they're on different sides. One's above, one's below. So those are alternate. And you'll notice they're outside of the two parallel lines. So we call that alternate exterior angles. They're both obtuse. They match. They're in the same zigzag. So we got to know that it's congruent because it's not the S rule. They're not same sides. Last but not least, number 9, 3 and 5. Okay. Oh, by the way, let's put these letters on here. This was what? E. And then this was C. So 3 and 5 leftovers here. They're on different sides of the transversal, in between the parallels. They're alternate interior angles. Again, not the S rule. They match. They're in the same zigzag. Those are congruent. All right. That is letter B. Cool. All right, down here, we want to classify the angle pair and decide if the angle pair is congruent or supplementary. All right. There we go. Now, first of all, the angle pair. Okay, here's an obtuse angle, and then here's an acute angle. They don't match. They're not in the same zigzag. Okay? So they look like they're on the same side of this transversal, but they're in between the parallels, so that's same side interior. Excuse my pen. Same side interior. And the S rule tells us that it is supplementary. So do not set them equal, right? If they're supplementary, they're not equal. That's what congruent is. Supplementary is when you add them together. So I'm going to have 5x plus 55. And then supplementary tells me to add them together. Plus 10x plus 5. And that's going to equal 180 degrees. That's what supplementary means. Okay? All right. Let me get my pen to work. Give me a second because my pen. All right. Now, we can do some math. Here's my equal sign. So the x's are on the same side. So I can take the 5x and the 10x and combine like terms to get 15x. Also with the constant numbers, 55 plus 5 adds together to make 60. Bring down equals 180. And now I have a two-step equation. I need to get rid of this loner first. Opposite of plus 60 is minus 60. Cancel out. Bring down 15x equals 180 minus 60 is 120. Last step, to get rid of the 15 coefficient in front that's being multiplied, the opposite is to divide by 15. Okay, so we get 8. And that's all I have to do because it just said to find x. Cool. Alrighty then. What about 11? So we want to use that diagram, find HFG. First, the angle pair. So this is an obtuse angle. This is an obtuse angle. If you follow the zigzag, they match and they're in the same zigzag. They're going to end up being congruent. Now notice, they're on different sides of this transversal, outside the parallels. That is alternate exterior angles. And again, no S rule means they're congruent. We see that they match. They're in the same zigzag. Those are all different ways to tell if they are congruent. Now, since they're congruent, I am going to set them equal. So 3x plus 42 equals, right, that's when I put the equal sign, 5x plus 2. And now I can solve this. X is on both sides of the equation, so don't combine them. You got to get rid of the smaller x, which is 3x. So minus 3x, minus 3x. These cancel out. Bring down 42. Bring down equals 5 minus 3 is 2x. Bring down plus 2. Now, obviously, you have to get rid of a 2, but which 2? So again, we always get rid of the loner first, which is this 2 out here by itself. The opposite of a plus 2 is minus 2. 42 minus 2 is 40, which equals 2x. And then to get rid of that 2 that's being multiplied as a coefficient, we divide. That's the opposite. The 2's cancel. 40 divided by 2 is 20. Now, we did that part, but now we also have to find HFG. Okay, now, HFG, if you look at your picture here, HFG is 5x plus 2. So we're going to use 5x plus 2 but instead of just 5x plus 2, we got to put a 20 where we see x, because x is 20. So 5 times 20 plus 2. 5 times 20 is 100. 100 plus 2 is 102. Don't forget your units of measure for angles. It's degrees. Cool. Number 12. Kind of more the same idea. What is the relationship here? So again, outside angle, outside angle. Okay. Now, we don't know if L and M are parallel, but we want to find X that would make them parallel. So what would make these lines parallel is if these alternate exterior angles were congruent. Okay, we don't know if they are, but if we treat them as congruent and get X, that would be the value that would help us prove these lines are parallel. So just like the last one, we are going to set them equal for x minus 13 equals 2x plus 37. Get rid of the smaller x, so minus 2x on both sides. 4x minus 2x is 2x. Bring down minus 13 equals 37. Get rid of this loner on the side with x. The opposite of minus 13, plus 13, plus 13. So 2x equals 37 plus 13 is 50. And then divide by 2 to get rid of a coefficient. X is 25. All right. You could plug it back in to get those values, okay, if you needed to. But bringing it down here, if x is 25, that means these two angles we know from the beginning are alternate exterior, and that would make them congruent. So the converse theorem we need is the alternate exterior angles converse, because that's what these angles are. Cool. 13. All right. Which angles are vertical angles out of these options, A, B, C, or D? Okay. Now, if you look at 1 and 2, those are not vertical. Vertical are across from each other at an intersection, like this. So what about 1 and 3? A, 1 and 3, they're across from each other at an intersection. B is right. Cool. What about 2 and 7? 2 and 7, no, those are same side exterior, so not that. 2 and 6 are corresponding, it's not that. Okay, so now the second question, what are linear pairs? Remember, linear pairs are next to each other. They look kind of like this. Right next to each other. Not across, but right next to each other, making a straight line of 180. So let's look at these answer choices again. 1 and 2. Hey, yeah, 1 and 2 make a straight line. So yeah, letter A is a linear pair. 1 and 3 is vertical, so it's not linear. Again, 2 and 7 are same side exterior. 2 and 6 are corresponding. Those are not linear pair. Okay. So that's how you tell that stuff. 1 and 3 are vertical. 1 and 2 are linear. All right, number 14. Which of the following cannot be used to prove two lines are parallel when cut by a transversal? Okay. Now these are to prove two lines are parallel. You got to use your converse notes. And for converse, there's only 5 things you can use: alternate interior, alternate exterior, corresponding, same side interior, same side exterior. So let's see if A is right. Again, we're trying to figure out which one cannot be true. Cannot. Very important. I'm not saying which one is true, because then there would be like 3 answers. Cool. So this says if same sides are exteriors are supplementary. That one actually is true, right? If same sides are supplementary, then it's parallel lines. That's true. Two lines are cut by transversal, so alternate exterior are congruent. That's actually true. Remember, it's not the S rule, so alternate exteriors are congruent. That's a true statement. That would prove lines are parallel. If two lines are cut by a transversal, so that a pair of alternate interior angles are congruent, well, again, we know alternate interior are congruent. So if that was true, it would prove the lines are parallel. Okay. Letter D, we have a transversal cutting two lines such that we have a linear pair that is supplementary. Now, linear pairs are supplementary, okay? While true, that's not one of our converse theorems, right? This is a big no. Linear pair and vertical angles are not going to prove two lines are parallel, because linear pairs and vertical angles are at one intersection of two lines, not a transversal of a line through two other lines. Linear pair just takes two lines, but the rest of these take 3 lines, 2 cut by a transversal. Okay. 15. Okay, what's true about this figure off to the right? Now notice all the answers are degrees, so I'm gonna have to figure out x and then plug it back in. Okay. So this is a linear pair because they're right next to each other. Right? They make a straight line of 180. So I'm gonna add these up. 3x plus 45 plus 4x minus 5 equals 180. Since x's are on the same side, I'm going to combine like terms. 7x. Take these constants, numbers, combine like terms, get 40. It equals 180. And then get rid of this loner. Opposite of plus 40 is minus 40. 7x equals 140. Divide by 7. And I get 20. Now, if you just pick letter C because you see 20, that would be a mistake, okay? Let's plug in 20 right here. So 4x minus 5 is 4 times 20 minus 5. 4 times 20 is 80. 80 minus 5 is 75. Okay. So this is 75 degrees over here. And the vertical angle right across is also going to have to be 75 degrees. See how that works? Now you could take this and plug in 20 as well. 3 times 20 plus 45. Ooh. $60 plus 45 is 105. Okay, so, or you could have just subtracted 75 from 180. Either way, you get 105. Okay, so there's more than one way to do this usually. So this big obtuse angle is 105, and then the vertical angle across from it is 105. Now, why did I label all those angles? Because this is a tricky question, and they're trying to see if you actually are reading, okay? This says it's BED 105. So if you trace from B to E to D, that's an acute angle of 75. It's not 105. Follow with your pencil, C to E to B. CEB, this big angle is 105, not 75. Sorry. AEC is 20. Now look, AEC, there's none of these are 20. That's just X, so that's not right. AED, from A to E to D, that big obtuse angle is 105. That's good. All right. All right, let's go on to number 16. Coach Mike McCarthy of the Dallas Cowboys was studying the streets or the roads in Arlington. You notice the streets illustrated parallel lines cut by a transversal similar to the image below. So see this picture to the left, imagine it's streets, okay? If Coach Mike knows the measure of angle 4, so he knows this angle already, which postulate helps him prove that 4 is congruent to 6. So look at 4 and 6. What are those angles? Well, those are alternate because they're different sides of the transversal. They're interior because they're in between the parallels. So my postulate that would prove that those are congruent is the alternate interior postulate, just like those angles, okay? Very good. 17, in order to better investigate some of the relationships in the figure showing two pairs of parallel lines, Dak traced the drawing on patty paper so he could better compare the angle measures. Now, which of the following conjectures Dak made about the figure would be incorrect? Okay, we know Dak is never incorrect, but this is fiction for math, right? All right, all alternate interior angles are congruent. Okay, now again, you got parallel lines, you got parallel lines. Okay, we know alternate interior are congruent, that's true. I want to know which one's incorrect. All right. Do I know, what about linear pairs? Linear pairs make a straight line, which is 180, which is supplementary, that's true. Corresponding angles, it says are supplementary. Now hold on. The supplementary has to be the S rule. S rule is only same sides are supplementary. So is corresponding a same side? No. So that seems like it'd be incorrect. Is the last one true? Vertical angles are congruent. That is true. So again, you're picking the wrong one. Corresponding angles are not supplementary. It's crazy. All right. 18. This is what we've been doing the last couple of days. Okay. What's true about AB and CD? Now you could graph this if you want. You don't have to. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. 1, 2, 3, 1, 2, 3, 4, 5. 0, 1. 5, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Now you can see something about these lines already. All right, so what do we know about A, B, and CD? Just looking at them, they do look kind of parallel. But we want to use the slope formula, y2 minus y1 over x2 minus x1. Okay, so AB is 5 minus negative 2 over negative 3 minus negative 8. So I can take this over here. Control divide 5 minus negative 2, negative 3 minus negative 8. I got 7 over 5. Cool. Let's do CD now. Y2 minus y1, 8 minus 1, x2 minus x1, 5 minus 0. You can maybe do that mentally, but 8 minus 1, 5 minus 0. Whoa, 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 whoa. I got 7 over 5. What do you know about that? So, we subtracted our y's, we subtracted our x's. Okay? We got the same slope. Same slopes means it's going to be parallel. So, they're parallel. That's great. Cool. Let's do the same thing on number 9. All right, wx, yz, our vertices. What is true about wx and yz? All right, well, again, parallel, skew, perpendicular. Let's go ahead and find the slopes. Okay, so wx is going to be y2 minus y1, so negative 1 minus 5. X2 minus x1, 3 minus negative 2. And I got negative 6 over 5. Cool. Now let's do the same thing for yz. y2 minus y1, 7 minus 2. x2 minus x1, 12 minus 6. 7 minus 2 on top. 12 minus 6 on the bottom. 5 over 6. Now this time the slopes are not the same, so it's not parallel. So it could be either skew or perpendicular. Now, notice, these two slopes have two changes. The first change is the positive negative sign has changed, right? Negative 6 over 5 becomes positive 5 over 6, so that's one change. Now that doesn't make it perpendicular by itself, but notice 6 over 5 is now 5 over 6. It flipped. So if you change the sign and flip the fraction, what do you call that? Perpendicular. So guess what? It is C. If it was not both of these, you would have to say it's skew. Maybe not enough info. All right, last one, number 20. Okay. Which of these is not true? Very important. Which one is not true? Okay, now remember this means perpendicular, the upside down T. So is P perpendicular to N? P, N makes a right angle. That's true. Is N parallel to M? N, M, same slope? That's true. Is M perpendicular to P? M, P, oh look, that's also perpendicular. That's true. And then is P parallel to N? Here's P, here's N. Those cross, they're not parallel. So this one is a no-go. So that answers the question, which one is not true. Make sure you have this review done. Finish it, complete it, and bring it to your test on Thursday or Friday too if you are finishing or if you were absent Thursday. Bring your review, please. All right.